All right, Math 2 folks. Hopefully your week is going well. We are approaching this second section in Unit 9. And Unit 9, again, to refresh your memory, is all about area of two-dimensional figures. So we spent a good chunk of time earlier this week, hopefully you did this, focused on triangles and rectangles and parallelograms. Kind of supplement that now. You'll have all the shapes you really need. Talk about circles and trapezoids. Now, I mentioned the other day you can cut trapezoids into triangles and rectangles. That's always a good idea. Sometimes it's nice to have a trapezoid formula, which we'll get to. And, of course, curved figures, we have to start talking about circles a little bit. Quite a bit at the end of the year we'll be talking about circles. Just read through this scenario here for Sally, and then we'll talk about this picture and how it relates to that. So, hopefully you had a chance to read this. Sally's trying to find the area of a circle. And of course, Siri, she got mad at Siri. She dropped Siri, threw her against the wall. She broke. Siri can't give her the answer. So what the heck is she going to do now? Can't call anybody, you know. What's she going to do? She does know the perimeter of a circle. Now, I usually ask people in class, hey, what's the perimeter of a circle? And somebody really remembers it's called the circumference. Good. Circumference is 2 pi r. People go all over the place. If you call it pi d, you're good. I like to use 2 pi r just because I like to, have r in that formula for me. Pi d is the same thing because 2r is d. So the idea is we're going to use this formula to invent a formula for area of a circle. So what I did is I took this circle and I cut it up into a bunch of shapes, a bunch of pieces of pie here. And then I took all the pieces of pie and I arranged them here. They were yellow, blue, yellow, blue, yellow, blue. I arranged them here to make them a shape you're much more familiar with. Now, what kind of shape does this look like from the last section? Hopefully you're thinking parallelogram. That's basically a parallelogram. Now, it's a little lumpy here because it's not perfectly straight here. But if I were to cut this up into even smaller pieces of pie, it would make this almost flat. And if I had... I don't know, I probably have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 16 of those. Imagine there were 160 of those. This curve would be almost not even noticeable if I had 10 times as many triangles in there. That's a big concept. If I could get an infinite number of triangles, this would be flat. Infinitely flat. I shouldn't say triangles. They're almost triangles. Now, think about how long this is. This is the length of all of these blue sections, right? The base of this parallelogram is each of these blue sections, and the blue essentially is half of 2 pi r. So this dimension is just pi times r. Next question I'd have for you, if we're trying to find the area of a parallelogram, that's base times height. Think about what the height of each one of these are. Anywhere you're going here, what's the height? Well, the height comes from one of these little triangles. So the height is the radius of this original circle on here. So essentially we're deriving this formula going, hey, wait a minute, a circle is really a bunch of triangles. I can take those triangles and rearrange them into, and I say a bunch because it could be an infinite number of triangles if I really did this. I could make those triangles, rearrange them into a parallelogram, which I know is just base times height. Each one of these had a height of r because they came out of the circle. Each one, this whole thing together has a base, if I put them all together, of whatever 2 pi r is, the entire circumference, divided by 2. Cancel out the 2's, and you end up with pi r. And all of a sudden, you have a formula. If you multiply this base times this height, you now have the area of a circle. Pi r times r. Simplify this, and you should get pi r squared. Now, you might be sitting there going, whoa, that was stupid. What? I already knew the area of a circle is pi r squared. Well, in high school, we're expecting you to know where those formulas come from. And that's what this process is. Every single time I introduce something, we're going to show you where the formula comes from. It doesn't come from somebody smarter than you. It comes from you. You can understand where this formula comes from. So we want to make sure you understand how to come up with these formulas, where they've come from. There's many different ways they've been derived, but we want you to be able to understand it all can be broken back down into triangles, which is a weird thing to say, that a circle is an infinite number of triangles chopped up. That's what we want you to understand. That's a big idea that connects trig with circles, and they are really, really closely related. So try these 3 on your paper. I know you may have already dove in on these things. They're not hard. Give them a try. I'll come back in part 2 and see if you got all these answers correctly. Trying to find the shaded region here, which I think you have to draw that line on your paper. Shaded region here, and that's already shaded there.